Oh, it's a lovely day. I think I'll go over to the cross. Yay! Roller ring! Ow! Oh, you saw those two balls? Yep. One of them was going over to the cross over there, and the other just bumped right into him. It's just like this, right here. When the two balls collide, it actually has Newton's first, second, and third law. Before they collide, so not yet, they're still going towards each other. Okay, they're not actually, bumping into each other. Well, for this, you can use Newton's first law. P1 equals M1 U1 plus M2 U2. So here the M2U2 is for ball 2, and obviously M1U1 should go to ball 1. This is the physical formula for the two balls not colliding yet but moving towards each other. Now we're moving on. Here is when they collide. When they're colliding, the formula for this is Newton's third law. This is the physical formula for this happening. FBA is for the ball A. They've all got the same force minus FAB, That's for the other ball. But here, even though the force is the same, because it's negative, it's moving on the opposite direction. The last bit of the after collision bit is a bit complicated, so let's run theories. Okay, now I'm going to prove that P1 equals P2. I can prove that P2 equals P1. So, according to Newton's second law, F equals ma, A can also be defined as the velocity, so the ending velocity minus the starting velocity over the time taken. So you could say F equals ma could be a whole new thing, and you could make it F equals m in brackets the starting the ending velocity minus the starting velocity over the time taken. So for this method, I'm showing you this because now you can come back to the FBA equals minus FAB. We could say that this right there, FBA, is the force of the first ball. And this can replace that. So it's basically saying that FBA equals F equals M the starting velocity minus, ending velocity minus starting velocity over the time taken. Because it's ball 1, we have to make all of these 1. Make sense? So just add the 1. Now we're moving on to ball 2. I have to add a little minus there. Now we know this. From this, this whole thing now go down here. So we know the force applied is the same, so we can get rid of the force. So all we need is M1 V1 minus U1 over time taken, then equals M2 minus M2, sorry, because we don't need that F2, the force are the same, and minus M2 V2 minus U2 over time. Well, they're both timesing the time, so we can get rid of the time, get it down, and what's left here is M1 V1 minus U1 equals M2 V2 minus U2. Ah yes, I forgot about this minus. So here we have it. So here comes the hard bit. P2 equals P1. And here's something to understand before I will write this formula. Now we can get rid of the brackets and say M1 V1 minus M1 U1 equals, so M2 V2 minus M2 U2. This one used to have it has a minus on it, so if this has a minus on it, it's making this plus. So I think it's safe to say that it's plus M2 U2. Stupid. U2. Good. You don't need to worry about this first bit, you just move it down. M1 V1, but when you get this minus M2 V2, it becomes positive when it goes over here. So M1 V1 plus M2 V2. Okay, I think I did the ones too big though. So once you get that, you should come and see that it's the P2. And now we can come and get the other stuff. So here we have M1 U1. So let's box this in. M1 U1 plus M2 U you get the point. Here comes the M1 U1 and stuff. Plus the M2. Okay, I think I forgot to do this. But add it in. And now we can, it's safe to say that P2 equals P1. Thanks for watching. This has been a very tiring video I've been making. This is what we get in result.